Welcome back to Jackson Square. Today we'll be looking at 6.4G. I can generate equivalent forms of fractions, decimals, and percents using real-world problems, including problems that involve money. So we're going to be working with word problems, which I know is everybody's favorite thing, right? Just kidding. Okay, so let's look at number 2. Mark, Rhea, Holly, and Travis compete in a contest to see who can bike around the school the fastest. Mark's finishing time is 3 and 125,000 minutes. Rhea's time is 3 and 860 minutes. Holly's time is 3 and 1/8 minutes. And Travis's time is 24/7 minutes. Which students complete the contest in the same amount of time? Mark and Rhea, Travis and Rhea, Holly and Travis, Mark and Holly. So first of all, you want to make sure that you write down all the, let's use our cube strategy. We can circle all the important numbers. We can underline the question. We can box in action words. Right now, we're looking for more than one student, and we're looking for them to have the same time. If you look at it, you see that some kids have decimals, some kids have mixed numbers. We see an improper fraction. So there's a mixture going on. Well, now we know how to do all those things. We know how to make a mix, an improper mix. We know how to change those mix to decimals, hopefully, and we know how to change those decimals to fractions. So we know how to combine all these things. So I took the liberty of jotting down these important points, and we're just going to start looking at them. And also, I'm going to be using my table. You guys have one similar in the front of your notebook. So this is just my table that I use for my FDP and for my conversion. So it'll be off on the side. If you see me looking and referencing, I'm looking at my table, and you can use yours in your interactive notebook as well. So here are the times. I'm trying to see who has the same time. So there are some options. We can convert everybody to decimal. We can leave everybody as a mixed number. You have your choices. So I think the easiest thing for me would be to make everybody a mixed number, because 2 of these are already mixed numbers, and I know that I'm going to make this a mixed number. So I'm going to take Mark and convert 3 and 125 thousandths to a mixed number. Hopefully you have been studying and you know that 125 thousandths is just 1/8. So I would write 3, that's my whole number part, and then I turn this decimal part into a fraction, which is 1/8. 3 and 1/8. Then I see that Re is 3 and 8/60ths. Well, 8/60ths I know can be divided. I know because it has an 8 in the ones place and a 0, it can be divided by 2. But I also know I can go a little bigger and divide by 4. 4 will go into 8 2 times. 4 will go into 60, 1, and then 2015. So this will be 3 and 2/15. This is already 3 and 1/8, so that one's good. And Travis, we have to do what? T-bow. Top in, bottom out. What times 7 will give me closest to 24? 3. That's 21. I subtract. I have a remainder of 3. So Travis will be 3 and 3/7. Okay. So the question says, which students have the same time? So who finished this race in the same amount of time? So when I'm looking, I see 3 and 1/8 here, and I see 3 and 1/8 here. Those are the same times, right? Everybody finished in 3 minutes. Some longer, some shorter, but who had the same? So who had the same? It would be Holly and Mark. They had the same finishing time for the race. So that would be the answer. If we were looking at the multiple choice, it would be F, okay? So changed all of them to the same thing. You could have changed them all to decimals if you wanted. You could have changed them all to mixed numbers like I did. Whatever you feel comfortable with doing, but all of them have to be the same so that we can equally compare them. Okay, our next problem says, I think that's Jolie, I'm not sure. Jolie surveys the students in her class to determine their favorite frozen custard flavor. This table shows the results. So in the table, we see that 8 students like vanilla, 10 like chocolate, 5 like strawberry, 2 like lemon. Which statement is true? Okay, which one is true? So if it says which one is true, like which statement is true, that means 3 of these are going to be wrong, and we're looking for the one that's right. So it's a little bit like the capital N-O-T, where 3 are right and you're looking for the one that's wrong. Okay, so 3 of these are going to be wrong, and there's only going to be one that's right. It says A, the part of students who like vanilla is represented by the equation 8/20ths, which is 34/100ths. B, the part of students who like chocolate is represented by the equation 2/5ths, which equals 20%. C, the part of students who like strawberry is represented by the equation 1/5, which equals 5/100ths. And D, the part of students who like lemon is represented by the equation 2/25ths, which equals 8%. First of all, we got to go and work every single one of these. We have to figure out which 3 are wrong and which one is right. So you can't just read them and be like, oh, okay, I know. No, you don't know. You have to put in some work to figure it out. Anytime they give you a table like this, if they don't tell you how many kids were surveyed, that's the first thing you need to do. The very first thing you need to do is you need to add up all the kids that were in the survey. So who was in the survey? How many kids were in the survey? So again, I took the liberty of doing this in advance, and I wrote down everything. 5 times 2 is 7. 7 plus 10 will give me 17. And then 17 plus 8 will give me 25. So how many total kids took the survey? There were 25 total kids. So why is that important to know? Because as we were looking at it, we kept seeing out of 25, out of 25, right? This is my denominator. We're going to be writing fractions, and this is my denominator. So I'm going to try to keep my chart, my table, a little bit visible just in case we need to see it. So that's going to be my denominator in my fraction. So just to verify, let's see. I wrote these problems from the vanilla was 8, chocolate was 10. I'm just gonna write a 10 right here. Strawberry was 5, and lemon was 2. So 2 out of 25. So this will be 5 out of 25. This will be 10 out of 25. And we're just assuming that they simplify these fractions, right? So I just want to make sure this is 8 out of 25. All the numbers are right. Now I can go ahead and cover that up and zoom in so you guys can see. I'm going to move the book to the 4th piece. 3 of them are wrong. 1 of them is right. Which one is going to be right? So the first one was 8 out of 25, which could not be simplified. We need to know, is 8/25 actually represent 34/100? So hopefully you remember that 25 is a friendly denominator that I can multiply to get my 100, right? I was looking to see if I had my paper with my hundreds on it, but I don't think I do. Yes, I do. Ha Factors of 100. All right, so here's my factors of 100 paper. What times 25 will give me 100? 25 times 4 will give me 100, okay? So I'm going to say 25 times 4 gives me 100. If I multiply 8 times 4, 8 times 4 will give me what? 32, okay? So making this a decimal, that would be 3,200. 3,200s, 3,400s. Are those alike? No. So is A right? No, A is not right. They do not match up, okay? So let's go to B. B says 10 out of 25 people liked chocolate. So 10/25, they simplify by 5. 5 will go into 10. 2 times 5 will go into 25. 5 times. So that's how they got 2/5. Awesome. 2/5 is 2/5, 20%. So you can do this two ways. You can think about your fifths on your hand. 2/5 is 40 hundredths, right? Or 40%. Or you can do our little friendly number trick. Remember, 5 is one of those factors of 100, right? So you could do 5 times 20 to get 100, or we can go to 10, right? It's quicker. So I'm going to do it over 10. 5 times 2 is 10. So 2 times 2 is 4. So I would get what? 4 tenths. Which 4 tenths as a percent, 1, 2, add a placeholder, will give me 40%. 40%, 20%. Do those match? No. Chocolate is not correct. Let's look at strawberry. So strawberry was 5/25. Again, they used the GCF of 5 and simplified down to 1/5. And they said 1/5 is 500. So hopefully if you know anything that I taught you about the hand, you know that 1/5 is 20 hundredths. So right off the bat, we know that this is not right. But if you like to prove it, you can go and say, hey, 1/5, I'm going to make it to something over 10, a new equivalent fraction, times 2, right? 5 times 2 is 10. 1 times 2 is 2. That will give me 2 tenths. 2 tenths, 500. Not the same, okay? It's not strawberry. So at this point, we're like, it has to be lemon, right? Just by process of elimination. Well, we want to make sure that we check and verify that it's lemon, because we could have done something wrong in all the other ones, right? So we always want to check. So 2/25. Again, what can I multiply times to get 100? Times 4, times 4, 800. Okay, we're cooking with some grease now, y'all. 8 in the hundredths place. This will be 8 in the hundredths place. Remember, it's tenths, then hundredths. Well, what would this be as a percent? To go from a decimal to a percent, 2 places to the right, my decimal point would be there. So it would be 8%. The answer is lemon. This one is true. Which one is true? The lemon is true. So it seems like it took a little bit of work, but it really wasn't that long. It didn't take hard. Again, for chocolate and strawberry, you could have used your hand and eliminated those quickly. For vanilla, you could have multiplied that 25 times 4 in your head and knew that 4 times 8 was 32 and done that quickly. And the same for the vanilla, right? So the answer is lemon. We have one last problem that we want to look at together. Number 6. Okay. It says, Miss Mosley asked her students to write a group of equivalent numbers. Below are the responses from 4 of her students. So we see Kason, Ella, Jack, and Caitlin. Which of the 4 students completed Miss Mosley's task completely? Completely? That's not what the word says. Correctly. Which of the 4 students completed Miss Mosley's task correctly? So we want to see which student has 3 equivalent representations, fractions, decimals, and percent. So we have to check their work. So we know there's more than one student because this is which of the 4 students. So our answer is going to be more than one student. Again, I've taken the liberty to write these numbers down for us. And again, we just have to go through each one and see if they did it right using what we know. So the first one says 207%. It says 2 7/10, 2 7/100. So off the bat, I know that this translates to 2 and 7 in the tens place. These do not match. They are not the same, okay? And then if I took this and I made it a percent, 1, 2, this will be 270%. So this doesn't match that, and this doesn't match that. So Kaysen did not do his work correctly. So bomb on Kaysen. Let's see Ella. She has 12 fifths, 2.4, or 2 and 4 tenths, and 24%. So let's go. If we started with 2 and 4 tenths, and we made that a percent, again, 2 places, 1, 2, that'll be 240%. So this doesn't match. 12 fifths, you can do Tebow. 12 in, 5 out, 5 will go in 2. That's 10. I subtract, I have 2 left over. That is remainder of 2. 2 and 2 fifths, which again, if we go to our hand, we have that 2 fifths is 40 hundredths or 4 tenths. So this is the same as 2 and 4 tenths. So this and this match, but the percent is not correct. Okay, all three have to be correct. So 12 fifths is the same as 2 and 4 tenths, and 2 and 4 tenths, these two match, but the percent is not. So Ella gets a bomb on Ella. Let's look at Jack. Jack has 2 and 125 thousandths, 212.5%, and 2 and 1/8. 2 and 1/8. Again, if you know anything, if you've been studying your charts, here we know that 1/8 is 125 thousandths, okay? So I can take this decimal and I know that it's 2 and 1/8, okay? So far this one and this one matches. If I had this decimal form and I want to make this decimal a percent, I'm going to move it 2 places to the, hold on, let me see if I can get a better focus. Yeah, 2 places to the right, 1, 2. My decimal will end up there. Does this match? Yes, it matches. So 3 checks. Jack is right. Good job, Jack. Good work, Jack. Let's look at Caitlin. Caitlin has 2 and 2 hundredths, 101 out of 50, and 202%. So we can go from here to here. If this is my decimal, I would move it 2 places, 1, 2. That would give me 202%. So that checks out. If I wanted to go from my percent to a decimal, I would 2 places to the left, 1, 2. That would give me 2 and 0, 2 and 2 hundredths, which is the same as this. So these two check out. Let's see here. This would be Tebow. Again, top and bottom out. 101 divided by 50. I know that 2 times 50 will give me 100. I have a remainder of 1. This will be 2 and 1/50. Is that 2 hundredths? Well, let's see. If I wanted to make 1/50th into something over 100, what would I multiply by? 2. And 1 times 2 is 2. And that's 2 hundredths. So this is the same as this. So all 3 of these are the same. So Caitlin, rock it out, Caitlin. So which students did their work correctly? The 2 students who did their work correctly would be Jack and Caitlin only. Jack and Caitlin only. So I hope that this helped and gave you some strategies on how you can use your knowledge of generating equivalent forms of fractions, decimals, and percents using real world problems. And I hope that this helps you with your practice that's coming right up. Good luck.